Hello everyone, my name is Zenokami from Essence of Zen. Today we're going to bring you a tutorial about how to convert binary into hexadecimal, or hex for short. So, welcome to the call stack. Now, if you haven't seen our previous videos about converting certain types of numbers in different bases, like binary, decimal, and decimal to binary, then you can find those videos here. Likewise, you can find a complete program that, well, it's not complete just yet, but it should be completed by the time a week from now, a week from this video. Anyway, you can find a program that brings out these algorithms in terms of full-fledged, manipulation of data here. Today we're going to focus on the actual properties of hexadecimal, mainly binary to hex. So we're going to actually explain to you how that is in terms of a mathematical approach. Now, just like last time, we talked about how binary, bin for short, is basically a base 2 number, such as 1, 1, 0, 1 as base 2. And we have decimal, or DEC for short, which is like 1, 2, 3, or 123, which is base 10. Hexadecimal, or hex for short, is basically base 16. So it ranges from anywhere from 0 through 9, and then A through F. So for instance, 2B is a base of 16. Now, to do hexadecimal, you can use a long, well, depending on how great you are in math, you can use the long division to convert a decimal number into hex by basically taking, such as, say, 234 and doing long division with 16, and then getting the remainder out of every single operation, and then convert the remainder into hexadecimal format, such as if it's greater than 9, then it's got to be a number so long as it's less than 16. So less than 16 as in not including 16. And we'll do a video about that later, but for this particular video, we're going to do the shortcut, which utilizes using binary and decimal bases to get the hexadecimal. So essentially, what hex is nothing but converted a converted 4-bit binary number. So if you remember, a byte is 8 bits long, so half a byte is 4 bits long, 4 bits in binary. So for instance, like what is it? 1, 1, 1, 1, which is, memory serves me, is actually 15. So 1, 1, 1 in base 2 is basically 15 in base 10. So what you can take here is that, remember, hex is base 16. So as long as it's let me close that 0 off so people aren't confused. I draw my zeros with a cross through them. So 0 through 15, as in 16 numbers, since you're including 0. If it's 15, then since it's 0 through 9, then A through F, that 15 will be F base 16. Still confused? Don't worry about it. We'll basically explain this in a better terminology in a bit. So if you can see here, what we're doing is retroactively using our previous algorithms for binary and decimals to get the hexadecimal. So it's using previous things to convert a conversion to get your desired conversion. So for instance, if we had the binary number, let's get something weird, like let's go let's do 2 bytes long worth of data. So 1, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0, 1, 1. All right. This number here is binary numbers. It's 2 bytes long. So 16 bits. So if we take here, we can go through 1, 2, 3, 4, 5, 6, 7, 8. And now we have 1 byte and another byte. All right, from here, we can then split it up even more into half of a byte. So now we have 4 sets of, of binary bits, so 4 bits long, 4 sets of 4, and each set is now a hex, right? So what we can do now is basically convert each one of those hex sets into decimal. For instance, 1001 is the decimal number for 9, so 9 base 10. 1101 is 13 in decimal form, so 13 base 10. 1110 is 14 decimal, so 14 base 10, and 0011 is, okay, guys, this, please hope you guys realize this is 10. I'm not trying to write 6. It's the Wacom tablet. This is 3 base 10. So now that we have, where's my mouse? I can't see mouse. Okay, there it is. Now that we have 9, 13, 14, and 3. we're pretty much done. So 9, which is less than 10, so we're not gonna have a letter for hexadecimal. So for the hex translation, start from the left, we have 9. 13 is greater than 9, so it's going to be a letter. So if 10 is A, so we got 10, 11, 12, 13, 14, 15. 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15 is F. A, B, C, D, E, F. So 13 is D, 14 is E, and 3 is 3. So the binary number 1001110111100011 is the hexadecimal format of 9DE3. And if you're absolutely curious, the decimal format for this is actually 40419, which is 40,419. I'm getting notifications a lot today. So now that we have this out of the way, we have the algorithm, or at least the mathematical properties of converting and setting up and what is what in terms of 10 through 15 for hex. How do we transfer this into code? That is what most people are curious about. Code is very unique, it's very annoying at times, it can cause headaches and etc. The best way to do that is literally just convert your numbers. So we started with having binary, right? We're doing binary to hex. And I told you how if you every 4 sets of bits in binary is one bit in hex. So if you have a user who puts in a variable, let's say binary number 011, which is 3 in decimal, so number 3 in decimal, that's 3 base 10. We want to be able to convert 4 bits into hexadecimal. So the idea is saying this, the length of whatever the user inputs in terms of zeros and ones has to be divisible by 4 in terms of algorithm for the code. So that means if they input 011, we'll check is divisible by 4. Well, 3 bits is not divisible by 4 because it's 3, not 4. It's not a lovely even 4 number. So what you basically gotta do is somehow check to see how many numbers is it off from being 4 bits. A great tool to use is Modulo. So Modulo is basically getting the remainder of a number. So if you actually go and open up idle, and I use idle for quick testing. What we can do is basically have whatever length. So this is 3 bits long, so 3 modulo 4. It gives us 3. So this lets me know that, well, if I compare it to other numbers, so if we had 2 bits modulo 4, 2 bits modulo 4, not 5, we get a 2, and 1 modulo 4 is 1. This basically tells me this: if I do the length of a binary number, modulo 4, and let's say if I have 3 bits long modulo 4, it tells me I have 3 bits. That means I'm 1 off. I'm 1 number or 1 bit off from having 4 bits, or at least being divisible by 4. What's a great way to check for this is, let's start with the number 6. 6 modulo 4. We get 2. That means we are 2 numbers off from being divisible by 4 nicely, i.e. 6 plus 2 is 8, meaning 8 is divisible by 4. We will have 2 hexadecimal items. So that's how we can use modulo. For this instance, it doesn't always work for like other greater numbers and etc. But for this instance, we can use modulo to define that. And once we have the modulo, so we know that 0, 1, 1 is 1 item off from being 4 bits or divisible by 4, then we know that we must add a 0. Add 0 in front if needed. So 0, 1, 1 becomes 0, 0, 1, 1. From here we have our completed nice even binary number. From here we'll just convert binary, so convert to decimal. All right, so 0, 0, 1, 1 is indeed 3. So then now we have our decimal number, so 3 base 10. Now we convert that to hex, which is 3. Now this may seem convoluted, confusing, a lot of work, but in my honest opinion, it's actually easier to follow rather than creating an algorithm for long division and keeping track of every single remainder, and then doing the long division of said remainder to grab another set of the hexadecimal number in that format. So if you want to go for it, by all means practice your ass off. But for this particular video, for us at ELZ, we're gonna try to keep this less complicated, but not so simple for some people, depending on who you are. So it's okay. So that's basically our algorithm. Get an input, check if it's divisible by 4. If not, find out how many zeros you got to add in front of it. Once it's rounded, take the first 4 bits, convert it to decimal, then convert the decimal to a hex, and then rinse and repeat until the original binary has gone from left to right completely. That's the algorithm. That is the pseudocode. That is neato. It's done. It's finished. Okay. So how do we basically do that? Well, if I open up a empty code, let's go ahead and create our main function. So I'll speed this up. All right, I'm gonna cut to here. So I'm creating a main function, and it's going to have an empty variable by the name of binary that is an empty array. Again, in Python, arrays are called lists, so it's up to you of the terminology that you want to use. So we're gonna call this an empty array because I prefer the term array. So just remember, arrays are lists, lists are arrays. In Python, they call them lists. In other languages such as Java, they call them arrays, but I'm going to call this list an array. So, if you hate me, I'm sorry. If you love me, that's wonderful. So we're gonna keep this as in, please input, let's actually make that number equals input. Right. Yeah. So what we're gonna do is have the user input, a series of, ones and zeros, and we're not gonna create, the user error checks and try-catch stuff, because I'm trying to not have this be an hour, just hopefully under 30 minutes, hopefully. I'm better than I was back in the day in terms of video production. So please input your binary number to convert to hex, and that'll be our actual number. So if you remember, the input built-in function, takes whatever the user inputs and it saves it as a string. So technically right now, right after you execute this code, number is going to be a string. Now we need that to be, binary. Wait, that's kidding. Ints. So actual numbers, something that we can use mathematical operations on. So what we're actually going to do is create a for loop, and then for every character that's inside of the string that the user did an input on, we're going to take every single character, convert it into a number, an integer, and then add it to the binary array. So to do that, we'll have a for loop. So for item in I want to say number. I could do the length. No, for item and number. We're gonna take binary. I think it's append. Yeah. Append int item. And what this does is it goes through every single character. It grabs that character for like the 0 index, convert it to an item. Convert it to an int, and then toss it into our binary array up here. So once that is actually done, we want to do a test, and let's say to show us that it's actually working. So binary number is do a space, do that, and then plus, and then we're not turning binary into a string. What we're doing is we're creating like a temporary instance of binary to print it out, and we use the string built-in function so that the compiler, or the console, the shell, can print out a string rather than like trying to print out a string and then int all. It's how the compiler works. So just yeah. And let's actually test this by actually having the main code call. Alright, so a little bit of the previous video got corrupted, so I have to add this in the middle of the video. So apologies first, and second, you didn't really miss much in between this quick cut. What you did miss is that I added the next portion of the code, which involves checking the length of the input, like we did in the pseudocode. So the idea is to use that modulo. Remember the 3 modulo 4, meaning we need to add one more so it to be divisible by 4. The idea of it is if the user inputs a particular data, let's say if the user inputted something like this, 001, right? So then we have a 3-bit number. So what we have to do from here is basically do we get the input and we turn it into an int like we did in the code earlier. And I'm just doing this for quick sake because apparently the code also got corrupted, and I don't want to go based off the official code because it's not the same that we used in the video. So then that we have our 3 bits, the idea is that we have to check to see how many zeros we need to add to it. So to do that, we're going to use the insert for arrays, but the idea behind it is we got to have like this range of things. So for instance, we use for like index in range 0 for print index. We can see that index range 0 to 4 prints out 4 numbers. So we can set up a set of conditional statements such as if the length of b, which is our array, modulo 4 equals 3. This basically means we're missing one number from being completely even for the divisibility of 4. Then we're gonna do for range. So we're only missing 1, right? Yeah. So for range, for index in range 0 to 1. we're going to b dot insert at index 0 1 0. See, now we have one extra 0 in front of our binary array, and we will basically do a lot of other elif statements like length b modulo for equals 2. It's a syntax error because we have to have the full if then elif, but etc. But if that was the case, then it would be for index in range 0 2 that, and then b dot insert 0 0, and so forth and so forth. So I'm about to end this little segment, and when it cuts back to the actual video, you're going to see the if and elif already completed. Sorry about that, guys. I literally cannot pull back the previous code to recover said footage. So again, sorry. So we stopped here at if the length of binary modulo 4 equals 3, then it's only need 1 0. Now you didn't really need to add the for index in range 0 1, but I did so anyway just to follow the same theme. So it keeps the same stylings, I guess you could say. Ooh, I forgot. That's elif, not if. Ooh, someone's probably typing in the comments to correct that. If, elif. All right. Usually you could have an else here and set up a condition, but again, we're not doing too much of a user proofing or etc. So this should be fine if everything works accordingly. All right, now that we've literally added how many ever zeros that we might have needed, we now need to go ahead and create a condition for moving any array into a temporary array, for converting it to decimal. So, you know, four binary numbers to convert into a decimal, and then that decimal to binary. We gotta have temporary, or temporary instances of a variable to hold data. So stuff that we're gonna eventually throw away. And it's a good thing we're running on advanced machinery. Otherwise, we would be very conscious about how much memory we were using. But again, that's for another video, for another time. So what we're actually gonna do now is create those temporary variables, such as number holder, and it's going to be an empty array, and it's grayed out because it's not in use, as well as I guess we can have decimal set, which is going to be another empty array. And that's basically when we convert the 4 bits into a decimal, we're going to throw that into this other array, and then we're going to have a final output, which will be hex number, and this will be an empty string or character, etc. So we're just gonna save those for later, because we're gonna interact with those 3 variables later. So what we're gonna do is have while the length of binary is not 0. I think that's right. If not 0, then yeah. So while it's not 0, we're gonna do some code or some actions, and that is basically what we're gonna do is we're going to take our binary array, grab we're gonna have a for loop that grabs the first number on the far left of said array, and we're going to pop. Now what pop is doing is it's the same computing or terminology for the old days back in assembly, where you had like a stack, and you would literally put data on top of data on top of data, was it first one in, last one out. So you would take whatever information is on the top, just the top part of the stack, the highest bit of data, and when you pop it, you take that out of the stack and use it or throw it away or whatever, and then you could get the next layer. And it's a whole different terminology for assembly and stack in terms of memory and etc. So what we're actually going to do is have a for loop, and it's going to go into an index of range of 4, because we're grabbing 4 bits per major tick. It's not really a tick, it's more of per operation. So for index in range 0 4, So for index in range 0 to 4, what we're gonna do now is actually take binary. No, we're gonna do number holder, and we're gonna pop, and then we're gonna actually get the we're going to append the data that we pop from binary. Pop 0. So what this does is it takes the first index of the binary array and adds it to the number holder. Now, again, why are we doing this? Because we want to convert 4 bits at a time to decimal, just 4 bits at a time. So we're gonna take the first 4 bits of binary and add them to a number holder. Once we're done with that, so make sure you get out of the for loop. What you need to do now is have the decimal set, and we would append whatever the conversion. So we actually got to do a function for converting binary to decimal. Luckily, we're going to use the same code that we had previously. Let me open it up off screen. Binary to decimal, binary to decimal. Here we are. Highlight all. Copy. So squeeze it in here. So we have a new function. Define the function binary to decimal convert. You input an array for the parameter. Decimal equals 0. The power is the length of array minus 1. So then for item in array, so we're going to start from the left, and then we're basically going to do decimal plus equals 2 times, you know, the 2 to the power of whatever the power is, times the item, so times 1 or 0, and then decrement the power, rinse and repeat, and then return the final output. So let's try, what is it? Decimal to binary to decimal? Yeah, binary to decimal convert. Number holder? Right, because we're gonna pass in the 4 bits of binary data, convert it to decimal, and then take that decimal and then put it in an array of decimals. Okay, kind of confusing, right? Possibly. Just stay with me. I could be explaining this not as well. I hope it comes off clear. So to test this, we're going to create a print out decimal set. So hopefully running it as a quick test will help explain it. So please input a binary number to convert to hex. So let's do 1 to 1. So this is only 2 bits long, so our code should add 2 zeros in front of this, right? Okay, well it did convert it properly, so we do have 3 into the decimal set. But let me actually binary, and then let me actually delete that here. Do now so you can see the difference. So if we run this again and put a binary number, so 1 1. So it starts off as 1 1. It sees that it's not divisible by 4, or at least, you know, it's not 4 bits long. So the code says add 2 zeros. So it adds 2 zeros in front of the binary number, and then it calls our conversion function, and then adds the output to the decimal array. And 1 1 is indeed 3. So that's good. We're right on track. Remember, always test. Always test. If you're still unconvinced, let's try a bigger number. Let's try 11011 1. So this is 5 bits long. So we need 3 zeros in front of this to make it, 8 bits or 1 byte. So let's enter it. So we have 11011, and we know we need 3 zeros to make it 8. So this is by 4 nicely. So it adds 3 zeros, 000110111, 11011, so 0001111. Awesome. So then it converts the first set, which is 0001, which is 1, and then goes back for the next 4 bits, which is what is that? That's actually incorrect. It's getting the wrong data here. So let's find out where we went wrong. Ah, indeed. Okay, so it's not 27, it's actually 11. That did look funny. The reason why that we got a 27 here is because we forgot to clear the the number holder. Once we get the first set of 4, we have to wipe out, we have to empty, we have to dump the contents of number holder to start fresh again. So after we do the conversion, we're going to add is it number holder equals an empty array again. So because previously what happened was we had 0001, and it had a 1 here, or 001 here still, and it just kind of tacked on to it already and then added it all together, and that is not what we wanted. So now that we dump this out, it should be fine now. What do we have for is 11011, was it? There we go. So yeah, same one before. 11011, added 3 zeros to the front to make it 8, and then it took the first 4, which is 1, and then took the next 4, which is 11, and now we have 1 and 11. So this would be in hexadecimal, it would be 1 and B, 10B, yeah, B. But we're not finished. We're not finished. So let me actually do this. Current set of decimals plus string. So it'll be easier to read next time. Okay, now we basically have everything we need. What's left is converting the decimal sets all into hexadecimal. Now, if you're wondering, if you're still curious, why do we need an array to hold the decimal numbers? Well, because if you're gonna have more than 4 or more than one set of 4 bits, you're gonna have more than one hexadecimal number. So see how we had 11011, which became 8 bits long. 8 bits means we're gonna have 2 hexadecimal numbers, which is why we have 1 and we have 11, which will be 1B. So that's why if we have anything greater, it's gonna be a longer set of hexadecimals. So when we convert this, we kind of got to do a little bit of long and tedious. Not really long, it's just I find it to be rather annoying, like really annoying. So we got to make sure we get out of the while loop, because now that the binary array is empty because we popped. Pop literally means remove and use. So now that we got through all of the bits in the binary array, we need to go through every index of the decimal set and convert all those decimals into hexadecimal. So basically, in Java, I would use a switch case for this moment, but because Python doesn't have switch case, it's just basically a set of ifs and elifs. So for index in decimal set, so basically we're gonna loop through every single index of the decimal set array. If index equals 10, it'll be hex number plus equals the string or the character A, and we're gonna do the same thing for 10 through 15. So speed up this portion a little bit. Finally we're done. So basically what it does is, if the index, so if whatever index that we're going through decimal set is 10, it's going to be A. If it's 11, B, all the way up through 15 for F. And then what we're going to have here is an else statement. Otherwise, 0 through 9 is perfectly acceptable. So we're going to have hex number actually equal plus equal, because we're adding on to the string. It's going to be string version of the, not infix, but index. All right. And then we literally just print out hex number. Let's make it a little bit more explanatory. So the hex version is plus string. There we are. Let me also make sure I add a space for the hell of it. And we're gonna run the code. Please input a binary number to convert. I like to use our previous one, which is 11011. So it takes a 5-bit long binary number, makes it 8 bits long, so 2 bytes. Then it goes through and says, hey, we have 0001, which is 1, and then 1011, which is 11. We throw in the first index, so index 0 goes through here. It goes, is 1 10, is it 11, is it 12, is it 13, is it 14, is it 15? It's none of these. So go ahead and just make it a string and throw it in as it is. So then the hex version gets 1, and then for the second portion, it goes 11. Is 11 10? No, it's not, so it's not A, but it is indeed 11. So throw in the string character B, and it goes there, and then it goes, okay, well, we're done because it was only 2 items long. Print out the version. And the new hex version is indeed 1B. And if you want to try it again with a longer bit of code, so I can just type in something random, 1101100100 whatever, and then hit enter. And then so it was 2 items short. I didn't know how many items it was. And then our final one is basically this long convoluted binary number. So it takes the first 4, which is 0110, which is 6, 1101, which is 13, 0000, which is 0, then etc. And basically it's just going to get 6, 13, 0, 14, 9, 5, and 11. So 6 would just be 6, 13 is D, 00, 14 is D, no, E? Yeah, E, 9 is 9, 5 is 5, and 11 is B. And then there's your hexadecimal format. So guys, sorry for if the video is a little longer than expected. I try to be quick without cutting out any explanatory bit of information for said video. If you're curious about the binary to decimal conversion function, check back to one of our previous videos. If you still want to see what's different, because this is actually an updated version of it from long ago. If you want to see more about it, we can do a quick video later. Just request it. But this is pretty much it. This is the algorithm for converting binary to hex. Essentially, converting hex to binary or hex to decimal will literally be self-explanatory. You know, 6 plus D, which is 13, and 0 E, which is 14, and you just add all that up. Just add it all up. Matter of fact, let's find out what decimal value is this long convoluted number. So I'm gonna do a quick calculation. Okay, it's a really big number. Let me cut this into segments. It is 114,354,523 in base 10. So yeah, a really big number. Let me make sure that this is also correct. So yep, that is actually correct. So guys, that wraps it up for the video. Leave a like if you like the video. If you disliked it, leave a dislike. Let us know why, so we can better improve these tutorials. If you have any questions, feel free to leave them in the comments below. When I can help, if I can help, I will truly try to get back to you as soon as possible. Please be sure to share this with all your friends who are taking, programming classes, trying to learn programming. Subscribe to see more. That's pretty much wraps it all up. You can find this literal program or an updated version of it at our GitHub. Here it's called Essence of Zen Python Number Converter. It's going to be a program or a set of code that basically is able to choose a function from a menu and convert whatever number you throw into it. You can find it over at our group's GitHub page. We'll have a link in the description below. If you like it, if you want to fork it and edit it yourself and find other stuff like the binary decimal converter and etc. Feel free. It's all open. We don't really mind you using it, etc. Just please give credit if you used it, or if you find out about it here. Just let other people know who may find it useful. And that again wraps it up for the video. So I have been Zeno, coming from Essence of Zen, of this kind of shell thing that we call the call stack. I will see you in the next video, but until then, as always, take care.
March winds and April showers make way for sweet May flowers, and then comes